Allen, and today, me and my group mates are going to discuss our C++ code for the Smart Streetlight Timer, a project focused on smart cities and intelligent lighting control. So in our scenario, a streetlight system uses ambient light readings measured in lux to decide when to turn on or off light automatically. The goal is to save energy by activating light only during low light hours. We use 24-hourly light readings, and if the light at an hour is below a set threshold, the light should be on, otherwise it stays off. Now, let's dive into our code. Guys!
Hi, guys.
Can you explain our code?
Sure. So first, let's go step by step through the C++ code. First, we include the iStream library
and include some constant.
First, const int hours equal 24 for the number of readings, 1 per hour. Int lux readings in hours, array to hold 24 hourly readings. Int threshold for the light threshold. Sum equals 0, sum of all lux readings. And active hours equals 0 is for the counter of hours when light was on. Next, use cout to prompt user to input 24 ambient light readings. We will then use a for loop to collect input from the user. So for open parentheses int I equals 0 semicolon I less than sign hours another semicolon I double plus sign close parentheses open brace then cout r I plus 1 then cin lux readings sum plus equal lux readings then close. So this loop reads the 24 light values and calculates the total sum. Again, use the cout to prompt user to input the light threshold and cn to input the threshold.
Now, once we get the lux readings and the threshold, we will now be computing for the average light, which is the int average equals sum over hours semicolon. Then next is we will be computing for how many hours the light will be on. So we will be using for the for loop. For int I equals 0 semicolon I less than hours semicolon I plus plus, then if lux readings I less than threshold, then active hours plus plus. Next is we will determine the streetlight status based on average light. We'll be using the string status equals average less than threshold question mark on colon of semicolon. Then next is we'll be printing the output result, which is cout average ambient light, then cout average lux, then end L, then cout streetlight status, then end L, then cout active hours light was on, then colon active hours, then end L. Then lastly, we will not be forgetting about the return 0. And also, don't forget about the curly braces at the end. So that was our code. I hope you understand it very well. Thank you!
Wait.
What's wrong?
I think they're forgetting something. Let's first test the code and run it if it's really accurate. Step aside, bro. Let's test it with a sample input. We enter 24 lux values like 40, 30, 30, 20, 25, 50, 70, 200, 300, 400, 600, 800, 1000, 900, 800, 700, 600, 500, 400, 300, 200, 180, and 60, and set the threshold to 300. The program outputs are
average ambient light,
341 lux.
and street light status off. For active hours, light was on 12 hours.
So this means that even though the average is high and the light is off, it was on for 12 specific hours and the lux was below 300.
So that was our code for our smart street light timer project.
So we use input-output loops and conditions to solve a real-world energy-saving problem.
Our logic ensures efficient lighting based on real-time levels.
Thank you guys. I hope you enjoyed the video.
Bye!